like that. So for example, there are several projects, including Wikipedia, for example. It's another collaborative project, open project, where citizens can contribute information. But there are different kinds of projects like the Galaxy Zoo or the Zooniverse, or even Foldit, which is a citizen science project to discover new proteins and new molecules, where people can just, using gamification, try to create new compounds. The one I put in the center is the one that we are working with mostly, is our flagship for the group, is called GEO-Wiki. And crowdsourcing and citizen science has several benefits in terms of data. Like, for example, you can get a speedy data production and data analysis. You have definitely low costs. You have the involvement of society, and if you actually plan and think through the applications that exploit this potential for citizen science, you can also create entertaining systems or applications, mobile applications, web applications, and so on. In our group and in general in citizen science, we use several engagement strategies. I mentioned already, for example, the gamification, that is trying to create an environment where some kind of competition or achievement of something is done on the platform. We also have campaigns where you have sometimes scores, competitions where you can win prizes, where you get rewards if you achieve some kind of level or some kind of you reach a certain point. If you are outside and you have a citizen science on the field and you are able to reach these places, then you also have some prizes. We also try to do some recognition, and because we also have a research mandate, in our case, we are always trying to involve the people that has contributed the most to these projects into co-participation of our publications, for example. Involve them into the generation of a scientific article, or several. Of course, some of the issues that we always are asked about is the quality of the data. This is normally what we call the wisdom of the crowd, the amount of people that you get to give you an opinion about a certain area or location or a question that you're posing on the campaign gives you an idea of how much or what is the range of answers that you can get for that. So, for example, normally we consider the number of contributions done in a specific location, the type of contribution, the performance of that specific participant, how often does it contribute something here, how fast. And usually we use, for example, control points, places where we know the answer, but we test the participants as they go. And get, of course, a reward or a correction or a suggestion on how to improve. We also look at the amount of contributions, but also the speed and the quality of those contributions. And we also provide, in some of our projects, near real-time feedback for the participants that are in the campaign. So today, I just want to show you some of the examples of the platforms and the campaigns that we have at IIASA. And this is, well, now, for example, with CIMMYT, we just have a newly signed memorandum of understanding. So we think it's good to do a dissemination campaign of all these things, so you can maybe generate some ideas for your own projects and your own activities here. I will show you some of the tools that so far are related to agriculture, and this includes, for example, some of the citizen science campaigns, but also what Isabel mentioned at the beginning, the collaboration that we have already with CIMMYT in the creation of this mobile app for farmers in Mexico. Another app that we have is called Grow. It's also a mobile app for agriculture and agricultural recommendations. And I will also show you additional tools that we have done for different purposes, like land use change, validation of maps or specific products, usually derived from Earth observation, like, for example, oil palm maps or nighttime luminosity maps and so on. Okay, so I'm going to start with the first applications and campaigns that we have most related to agriculture. And this is, of course, I was telling you a moment ago, we have this GEO-Wiki platform. It's an engagement platform for people to, and not necessarily only experts, but in general citizens, to engage in environmental monitoring. And this can be either by providing feedback on existing spatial information or contributing entirely new data. I will explain you a little bit more about this in a moment. What we do in this platform is usually create campaigns, citizen science campaigns. So for example, a couple of years ago we had a campaign that was called Cropland Validation, where we had a total of 80 volunteers that validated or reviewed on this platform 144,000 sites with 2,000 control locations to test their performance on that. And we also had experts, that is people that were related already with Cropland and Cropland maps, that did points for qualifying the people that was contributing in the campaign. So what we had is this sampling design, like this. This was a systematic sample across the world, just stratified by either a Cropland probability map. And then we created training materials. We had different satellite imagery, NDVI time series, OpenStreetMaps, all the different layers that were available to the people in the campaign platform, in the GEO-Wiki platform. Some of the control data sets were done in-house, either with experts or trained students, and we also had these gold standard expert validations that were introduced into the system, and we offered prizes for the first 30 people, or the top 30 people contributing to this campaign. The campaign lasted 3 weeks, and we evaluated about 36,000 points across the world, with of course being evaluated or validated several times. This is more or less how it looked like. So the platform, you can see, shows you a location, one of these samples of the selected locations. We overlay a grid on it, and then we ask, okay, how many of these grids has a cropland? And people were able just to paint on top of it, and then select if they had another comment, and they can just submit. They could also skip it, say, I don't see it, there has too many clouds, or I cannot really distinguish that or so. And there were supporting tools, like, for example, the display of the time series NDVI coming from different sources like Landsat, MODIS, Sentinel, and so on. And you can also get the yearly average of the NDVI at that particular point. And so these were sort of auxiliary tools for people to decide whether that is cropland or not, depending on how they see the seasonality and the change. They could also download the point and visualize it in Google Earth, so they could see additional auxiliary information like geotagged pictures and terrain, and make a more informed decision on whether that particular location is a cropland or not. Essentially, the question here was, is it cropland or not? So something similar. This is what was the result of the Cropland campaign. We created this map of cropland across the world, just in 3 weeks, with the participation of all these volunteers. We provided incentives. Like I said, this was a competition, so there was the possibility of the top people to also get involved in the publication of this paper. We actually did a publication in Nature Scientific Data of this, and the whole data set is openly available and accessible on a repository online. So this was one of the main. This is kind of the kind of results that we get from GEO-Wiki in the campaigns. A similar campaign was to determine field size, and what I'm trying to show you here is that, of course, we always have a plan on how the data is going to be crowdsourced, how many samples we have, how is the design of this. This campaign, for example, lasted 4 weeks. It had a bit more locations, 100,000 more locations, and it had 4,000 control points. The interface was very similar, but we also added additional customized tools. for example, a tool to measure the size of each plot. So you could just get the tool, draw it on top of it, and then you will get what is the total area of that plot and whether that means it's a medium, small, or large. And you could draw several polygons here, and then you will get you could answer whether you see medium, small, very large, very small points, and which kind of size is the dominant size at that location. So the question here was, what is the size of this? What is the average size of these fields, or what kind of sizes do you see in a certain location, and what is the dominant field size? Of course, we define what does it mean, well, whether it's a very small, medium, and large. And we also use this graphical sort of a bird's view of the size of the field size, and we said, okay, if it's smaller than one of these yellow cells, then it's very small. If it's larger or smaller than 4 of these, it's small, and so on. With larger than the blue one is a very large field. And that was, you could just immediately, very quickly say, okay, this is a very large, very small, or so on. You don't necessarily have to measure them, but you could also do it if you wanted to. Plus the additional facilities like before, you could download the point, you could see it in Google Earth, you could also send comments or ask the experts for help. That means we will get a question on a specific location and say, why I cannot say what is this here, what can you tell about this place? And there were, of course, materials prepared for this and an initial training before people get into the campaign. So you could tell them how to use all these tools and so on. This was all online and automatically done. This is the result from that. So this is the field size map that we got from this campaign. Is also an open data accessible online. So yeah, these are the kind of things that you can get with the tools. We also did some estimation. One of the first tasks that was to re-estimate the available marginal land for biofuels. And this was done another campaign in GEO-Wiki, and this was, of course, the number that we got here is not the actual number of hectares, but you can see that the difference between what was published before and the actual findings was quite large. So, and this was a campaign also that lasted a couple of weeks, 2 or 3 weeks. So, speed of data collection and the amount of data collection that you can get is an important thing here, and the participation of people. So, I'm going to jump to the collaboration that we have directly with CIMMYT, and I see many of you that we have talked already before, especially with Andrea and Luis and Kai, that we have been working with this. So this is a mobile app. So we have a group of programmers that create mobile apps for different purposes. In this case, the mobile app is called AgroTutor, and it's meant for crowdsourcing sustainable intensification, and it has lots of characteristics that allow people to store crop information and crop management practices. For example, ground preparation, sowing, irrigation, weed control. In each one of these, you will get an additional menu to add costs, to add amounts, to add time that you have required for doing this. In the interface of AgroTutor, you also have different layers that you have preloaded there, or you could also get an offline base map at very high resolution, at least from the National Mosaic Service from Mexico. You could also delineate the parcel that you just registered, and then you will get information about that parcel, including the weather at the parcel or the weather in general where your location is. So the whole purpose of this is that it has a set of tools, like, for example, historical cost, historical yield, recommendations for planting, for fertilization, price forecasting data that comes from very different sources. So some of these modules some of this information is directly from here, from CIMMYT, from the historical data from the BEM. Some of the information is processed information from BEM into models that can determine critical variables that determine yield or that influence yield. Some other modules, like for example, the market price forecast is run at IIASA and with the collaboration of the Vienna University, and tries to look at the time series from a trading hub for the last 20 years and makes a forecast for the next 12 months with a range of expected prices for that specific for the current month, they expect the next month, and in 2 months, 3 months, and so on. So the idea is that it has all of these crop models, including a yield potential model, which is the epic crop model, also run at IIASA, and several base information like weather, historical weather, forecast weather, current weather, like I said, historical yield, cost, benefits, included into this application, and can be easily targeted to the location of any parcel. So the farmer registers a parcel in a certain location, and that triggers the targeted information from each one of these. This is our expansion of AgroTutor, what we expect to get as we advance more and more in the future. We expect to add more modules here, like for example, pest and disease identification, or irrigation recommendations, or including pictures with a bit of augmented reality to guide people on how to take the picture for pest identification, for example, or for sampling, for soil sampling, or so on. But importantly too is that we're also targeting this to different places. Like for example, this is an example of how we would connect AgroTutor to Europe to do, for example, influences into the common agricultural policy by having farmers doing self-reporting of their practices, and then that affecting the amount of support that they get from the states or so. Additionally, connecting with insurance, and for example, if you can prove or you can show that the kind of practices you're doing are sustainable and are supporting reduction of emissions, or are helpful for climate change mitigation or adaptation, then you can, if you have some kind of disaster like a flood or a drought, a disaster fund could, for example, fund you back or support you on that. So this is so far what we have in mind about this. We don't have it yet there, but this is what we want to do. And I think many of the efforts from CIMMYT and from the group we've been working with are oriented towards that. Okay, you must be tired already. I hope not. I'm just going to show you one more app, and this is called Grow. Grow is an open application. You can also get it on the App Store or in Google Play. Many of the ones that I'm mentioning here, you can just, if you want to play, actually I encourage you to just download them and test them. It suggests practices or recommends crops adapted to local conditions. But not only, well, it also allows you to join. In this case, this was a project that was called the Grow Observatory. It was a citizen observatory of people reporting, in this case, agricultural conditions and practices in Europe. But the app could also suggest you what can you plant here right now, and there was, of course, a very basic description of what kind of plant is this and what does it need and what kind of requirements does it have. And as well as practices for sustainability, biodiversity, and so on. This was just a pilot project trying to understand if people were interested in these kind of things, and this was a part of a larger observatory where there were lots of people involved in teaching and talking with farmers and so on. But this was at the European level. But the technology here is very similar to what AgroTutor has, but this is more of a library of information for the producers and suggestions for sustainable practices or more environmentally friendly practices. Okay, so couple of tools that we use for different things, but that you might find that might fit some of the needs that you have here. And this is, for example, called a validation platform. It's called LACO-Wiki, or Land Cover Validation Platform. Essentially, in LACO-Wiki, you can upload a map of anything. For example, you may have a map of suspected farmers using techniques that CIMMYT has developed over the time. And you think these techniques might be there. So you have a map of that. What you do is you generate a sample. That is, you say, okay, out of this map, I want to sample all of the locations, or just do a statistical sample, or a random sample, or stratified random sample of the points that I'm putting here. And then you create a campaign to validate it. In the campaign, you decide what layers do you want to show the people. For example, you can show them OpenStreetMap, you can show them Bing, you can show them Google. If you have your open, like your web map service, like your own, say, aerial photographs or drone imagery, you just load it here. You just create it here, a web map service, and then the platform will read it and then will show it as a potential, as a layer that you can query and ask it to display here. And then you create a campaign, either for a reduced group of experts, or you open the campaign to everybody, and then you say, okay, I need help identifying what is here. And then people, for example, in this case, this was asking people, okay, is this what you're seeing, any of these classes, like is it cultivated, is it forest, is it grassland, is it buildings, is it bare ground? In the case, for example, that I was mentioning, you could say, does this parcel have X technique, yes or no? Or you could say, do you think this parcel has that technique, this technique, or that technique, and so on. Or you could also do a blind validation. You could say, is this correct, yes or no? And that's it. In the end, the system just generates an accuracy measure, so how many of those things that you're evaluated match what your map has said, and so on. So you get an accuracy report that you can reuse to correct your map or something like that. So this is an open platform. You can just enter here to lacowiki.net, and you'll see how it works. You can log in with Google, with Facebook, with GEO-Wiki also. We also have a login there, and it's free and open. Well, these are some of the things you can enter there: the zoom, the navigation, the layers, the overlays that you can put there, the type of validation that you want to have. And we also have now a mobile version of this LACO-Wiki. So you can create the sample in the web-based platform, and that sample then goes to this mobile application, LACO-Wiki Mobile. So when you are actually on the field, you can do the validation on site, and then decide, you can answer the question that is being asked, is this, that, or that? And so you can also get some imagery down, temporarily stored, and then use it for that. This is an example of how it was used to validate the European Space Agency land cover map at 20 meters. This was in Kenya, and this was done with a group of Kenyan geography students and agricultural students to validate the map from ESA, no? And we did the same in several countries in Africa. In this case, the validation showed that the map was not really accurate, but this is the kind of exercise that you get from that. And it's a very quick thing. This was a couple of, I think this was 2 days or so, and it was done. Okay, we are also adding into this mobile part the NDVI profiles, so people can do a more informed decision, and also some other functionalities that we have in other apps that I will show you in a moment, of how to get to the point that you are aiming to. So it will guide you towards the point. And the app that guides you to the point is called PhotoQuest. PhotoQuest is it's an in-situ data collection for land use and land cover change monitoring, and is based on the European Statistics Office. This is a 3-year survey called LUCAS that has hundreds of thousands of points across Europe, and we are using the same locations as Lucas as to prove how accurate can people be compared to the professional surveyors on the ground. Lucas had campaigns on the 2012, 2015, and 2018. And we run PhotoQuest on 2015 onwards. So we don't only have one campaign, but people that kept the app installed, they keep on contributing how this then looks like, how this point changes. So what you see on the application is the points that are nearest to you. So you choose a point and then you decide whether you are exactly the point, if you can reach the point. Sometimes there are, of course, private property, inaccessible and so on. So you have the possibility of saying that. And then you're shown pictures from the past at that point. In this case, for example, because we had the Lucas survey, and that is an open source of information, you can show the pictures of the land covered, land use at that point from the last campaign of Lucas. And then you ask, well, okay, is there a change, first of all? If you say no, you have to take the pictures and prove that it is not changed. But if you say yes, then you are shown this decision tree where you have to go, first of all, decide whether you're looking at water, bare land built up or vegetated. Then if it's vegetated, whether it's mostly trees, mostly grass, and so on. And if you decide, say, for example, cropland, then whether it's cereals or root crops or dry pulses or vegetables. And then you go one level down and you have a bit more information on how does wheat look when it's very small, or how does potatoes look like when it's very small in different stages. At this point, we were just looking up, we were just showing very open data about that. And then you're asked to take pictures. And so we're using the capabilities of the smartphone to use the compass. And so the app will only let you take pictures as long as you're facing the direction that you're being asked for. For example, south. We're always asking pictures in the north, south, east, and west, as well as a picture towards the point. And we give this indication. It has to be 1/3 horizon and 2/3 the rest of that, and so on. Those are general indications of how to take pictures. You can also blur things like faces and license plates and so on. So you send the pictures with those things blurred if you want to blur them. We also ask how homogeneous is the land that you're looking at, and we show some examples, okay, where you're standing, there's more than 50 meters, less than 50 meters, 20 meters, and so on. And we ask, okay, apart from that cover, the land cover you see, how is it used? Is it for forestry? Is it for recreation, for industry, and so on? Apart from that, on the last campaigns from PhotoQuest, once people send data, the data comes to the GEO-Wiki platform, and we look at the contribution, we look at where the people were. So this was the target, this was where the surveyor was, and this was where the citizen scientist was. And so we get an impression of how far it was, how close it was to the target. We see the pictures taken, we see if the pictures were of good quality or were too dark or so, and then we send a message back with some feedback. Okay, your pictures were too dark, or you were a bit far, or maybe you could have gone closer on the next time, and so on. This campaign, of course, had some incentives, and we were paying €1 per point visited. And on the last campaign, on general classes like, for example, agriculture, we have a match up to 95% with what the authoritative data from Lucas had. In lower qualifications like, for example, crop type, we had up to 78% match. So it wasn't that bad. Okay, another tool, perhaps it generates some more ideas. This is called PicturePile, and this is also a mobile app as well as a web-based app, so you can also play it online or so. And it has essentially been designed for rapid image assessment and detection of change. So it's very generic. You can customize it, that is, you can upload your own pile of pictures, or whatever the pictures, the topic of the pictures is. For example, we are now working with the Air Challenge with regards to the marine litter, but there's also poverty mapping and poverty detection, etc. We have used it also for damage assessment. Like this was a pile that was called the Hurricane Matthew pile. This was a campaign open specifically for humanitarian OpenStreetMaps contributors, and they were asked to mark whether there was damage, there wasn't damage, or maybe. So that's the only options you have on the app. You either swipe right if it's yes, swipe left if it's no, or down if it's maybe. And the only question is, do you see damaged buildings? In this case, for example, we had 179 volunteers, and we have almost 250,000 images validated of before and after. We produced, of course, some control images where we were showing where the damage and how the damage can be looked at or identified. And this is the very quick damage map that was produced right after. So this was 3 weeks with half of these images classified in 5 days. So in 5 days, we already had a rapid mapping of the damage. And now, for example, we are doing lots of work with poverty mapping by using remote sensing or by using also, for example, StreetView imagery. And then in picture pile, you can also drag the image to one side or the other, and then you will have a range of how poor or how rich does that look to you. And many people can contribute to that, and then, poverty mapping is one of those things that is essential to be able to track and direct resources to the right places, and the type of resources that need to be sent. And one other thing that we're using these piles is because we need large amounts of reference data for calibrating automatic recognitions or the use of artificial intelligence models. Like I said, we are participating now on the Earth Challenge. If you participate, you might see some of the apps that we have there in this year. And like I said, we use this large amount of data for calibration of automatic models, or for example, for places where the automatic recognition of images does not do so well, but we still, as a human mind, can do better than artificial intelligence. We use it, for example, also by using remote sense images for identification of poverty by roof type. We also have a person from, I think from Baja California, that is working with us in the automatic identification of crop type by using StreetView imagery. And we are also combining this with the crowd identification of crop type. So for example, now this is a new project we are working on to combine StreetView imagery and mapillary imagery with certain additional information like the crop calendars, and asking people whether they can identify what crop is that they're seeing there. Massively, no? So we plan to do this also on the Earth Challenge and so on. A different type of app is for reporting alerts. Like this is an app called Flood Citizens, and people. This was worked in 3 cities in Europe. It was, I think, Birmingham, Brussels, and I don't remember the third one. But the idea was to create a tool for the municipality for creating their own reports. And people could just report what they're seeing and then send the information, and other people could validate the reports. They also get some recommendations on how to respond or how to prepare about it, and they can register for receiving alerts from the municipality. So this was not a disconnected system, but actually working together with the emergency services from the city. Another type of app is for biodiversity. This was with BirdLife International, and this was created for them to allow people to report environmental threats wherever they were. And they could take a picture, they could specify the type of threat, the severity of the threat, and then they will be displayed in this dashboard where people could validate those threats if they were around there was a threat report, and then there are several reports from the same thread, and people could validate it. They're working also now with marine leader or with you know, trash dumping and so on. No? So this is another kind of focus of this. These were, for example, just a pilot in Spain and Indonesia with 55 participants and over 600 observations for environmental threats. Okay, perhaps just to close a little bit, I'm going to show you a couple of things that we also do. I mentioned to you that we also do this Earth observation and remote sensing. So one of the things we've been working with is night lights, and we had a joint collaboration with the World Data Lab in Vienna, and they have we created a map of North Korea and related the night light intensity of the lights of the cities or the countryside, which actually, as you can see, there's nothing, to the economic development, which is actually as much information as we can get from North Korea. This is just a publication that we had on the Economist about the status of North Korea's economic status of North Korea from 2012 to 2016 or so. We are also using, for example, data such as DHA's surveys in Senegal and in some other countries in Africa, and relating them to cell phone information, like the amount of calls in and out from towers across the country. So this was a data challenge participation that we had, and tried to map the wealth level across the country, combining these sources and then doing some validation with crowdsourcing afterwards. One thing that might be interesting to you, we also have a project that will start soon in Mexico regarding cenatons in terms of economic relationships and financial relationships. A cenaton is essentially these scenarios marathons. So there's lots of scenarios put together by different participants that can offer and take some inputs simultaneously. Like, for example, in Mexico, the idea is that different states participate, and each state say, okay, I can produce this much of this much of that, and this much of that, and I need this much of this and this much of that. And so this is done simultaneously with all the states, and there's some kind of compromise reached of how much this can be achieved. So this is an exercise on decision making, on participatory decision making. And this is just a very new project. This was done with several countries, but the idea is to downscale it here to Mexico and use each of the states as one participant. That's it from my side. So I hope it wasn't too long. I hope that you get an idea of what we can offer you in terms of tools and in terms of potential collaboration, and we hope to continue doing it in the next years. So thank you. If you have any questions, I'm open. Thank you. Any questions? Yes.
I was wondering if the slides.
I hear you anyway.
Now it's working.
Yes.
Okay. So thank you for your presentation.
Thanks.
It's very interesting to see what you can do. I was wondering about the AgroTutor application.
Mm-hmm.
So the screenshots that you show, they show that there's still a lot of work to the application. So I was wondering if we could use this kind of a crowdsource to improve the application that we have. What would you suggest we do?
But what do you mean, like to improve the actual?
The recommendation it gives.
Yeah, well, actually, one of the things you can do in the app is to provide feedback. It's included on the application. You can just press it, send some feedback, and in fact, the whole system of how it will be deployed here is is together with the extension agent. So it will be a very much driven by extension agents kind of tool. In this case, they will just sort of suggest the use for the farmers, but the idea is that triggers more adoption by farmers in general. And currently on the current version, yes, you can provide some feedback at least. So that will be some of the crowdsourcing. There was somebody also doing a baseline of current conditions for the farmers in Guanajuato, which is where we're going to start. And so we want to compare that to what happens afterwards, so we can understand what are the drivers and what people want to do. Plus, we are just having some meetings on how we want to expand it and what other services do we want to show and make it more attractive for people to adopt it. No, that's the whole idea. Plus the commercial part, right? So you also have to think of, well, how self-sustaining is this application? For CIMMYT, for research, it's very good that CIMMYT has some support for that, but we want to make it more useful in the sense of, say, people that can provide some services for the farmers maybe are interested in doing a forest support. This is not currently what we are doing, but this is probably where things will move to, I think. But for more information, you have to ask Andrea here for the actual deployment details.
Thank you.
Yeah, you're welcome. Any more questions? No? No? All right. I'm going to be here still today and tomorrow. If you have a particular project or idea that you think any of these tools can help you with, just tell me, and we can sit down and talk. So thank you for coming. See you.